ready for us. So, let's get into MATLAB here. I don't remember how far we got last time. We'll figure it out, I guess. We got into chapter 2. Chapter 1 is just kind of straightforward stuff. We got into chapter 2. We learned how to make an M file for saving our work in. We learned how to make some simple arrays. And I think that's about where we got to. We need to do some more of chapter 2 today. Before we get started with this, I'm going to take you into Blackboard. So to get into Blackboard, you go to mpcc.blackboard.com. And you're going to want to go to the central login for MPCC faculty and students. Then you log in using your email login or your whatever, campus web, same login, right? And then it will give you Blackboard. The course that you're looking for is Programming and Problem Solving here. And it will bring you to this front page. Here is the syllabus. I believe that it's updated properly, so let's take a look. This is our spring 2017 syllabus. So if you need to know kind of the idea of how things are graded and what we'll be doing in this class, there's the place to go. But the engineering essentially have two places to go to, well, three places. Engineering 1020, actually, there's only one place to go. You guys aren't seeing this. Let me fix this really quick. Let's go to student mode. All you're going to see is Engineering 1020 Home and the Help button. Because I put everything on one page just to make it simple. So you have your syllabus, which is the first button here. Then you have this file folder of weekly assignments. When you open up weekly assignments, you'll find the MATLAB Functions Tips and Tricks shared document. And remember that each week you are required to go in and make an entry. And I've reset it so that we're starting a new document. So you need to go in here, put your name, the date, and a tip, a trick, or some kind of function or some other thing that you learned in MATLAB that's going to be helpful to other people. Remember to read what other people enter in, because if you repeat something, you don't get credit for that entry, and that's worth part of your grade. We go back into our homework. We have week 1 assignment, week 2 assignment, so on and so forth, all the way up to week 12 assignment, and then the final assignment. These week by week assignments are, we usually keep up week to week. Right now we're a little bit behind already, just because we didn't get all the way through chapter 2, but we should be able to get through chapter 2 and mostly through chapter 3 today. It's not terribly difficult stuff we're doing, not until we get to chapters 4 and 5 do we do anything really challenging. But week 1 assignment, you'll open up here and you'll begin the assignment. You can go back and stop working and go back and work as many as you want. It doesn't take off any points for coming back, and you can change your answers or whatever. But here we have our first question, question 1. This one is creating a simple script in MATLAB. I want you to watch this video. If you click on it, it'll take you to this video on YouTube where you learn how to make a script. If you don't remember how we did that last time, it'll teach you how to do that. Then you will you'll create an M file with the commands used in the video and upload it here with the file name, your name _ w1p1.m. So week 1, problem 1. Many of your homework assignments at the very beginning of the class anyway will have this format for the file name, your name _ week 1, problem 3, week 1, problem 4, week 2, problem 2, whatever. So week w1, p1. Others you'll have to do differently because of what you're doing. But then you move on to question 2. These problems are similar to the ones in the book, but not exactly the same. So you will need to go down here and notice that it says predict the outcome of the following MATLAB commands and write them in your M file as comments. Remember the comment lines, you put in a percentage mark, and then you can comment. So you can say problem 1 plus 3/4. Will you put problem 1 with a parenthesis with a percentage, and then you can put a percentage mark and put 1 plus 3/4 equals 1 3/4 or whatever, or 1.75 or whatever. And you can make your predictions for how all these things will work. And then after you have predicted all these things, do this without using MATLAB. After you've predicted the results, check them by entering the commands into your M file and running it. So these later commands will actually be real commands. And then problem 2, you're going to use a function in MATLAB called the isVarName function. You're going to use that function to determine which name in the pairs below is a valid variable name. We'll learn how to do a little bit of that today. And then you'll, problem 3, you'll create an MATLAB code to perform these calculations. So you'll do all these calculations in problem 4 and problem 5 and problem 6. And then you'll attach your file. So you attach your file by browsing your computer. It'll give you the option to upload a file, and you put it in there. Then you save and submit, or save all answers. Either way, if you save and submit, I will get the grades. If you just save all answers, I will not get it will not tell me it's time to grade it. So that takes you through most of chapter 1, I believe. Let's see if we look in the book. That takes us through, most of chapter 2. Chapter 2, 1, 2, 3, 4, 5. It takes us through about the first half of chapter 2. Then, in second week, which is apparently we're splitting chapter 2 into 2 weeks, so if we go back to our weekly assignments, we're going to do problems from the second half of chapter 2. Let's see if that's correct here. Creating an array. Yeah. So I teach you to create arrays, and then we start, and some of these problems are not in the book, but they're problems that we're going to do. So, and this one I did it backwards. I did W2P2 yourname.m, so just follow the instructions. But you have 6 problems in this that you're going to put in this file as well, and then you'll be done. And different things that you'll do as we learn those things. Then we get into week 3's assignment. And we start having multiple, let's see. No, in this one we still just have one file. Multiple files start somewhere, I don't know where, but for the first 3 at least, we're only going to have one file that you're going to turn in, except for this right here. So this one is its own file. Question 1 is its own file. And then question 2, well, actually there are 3 files in homework 3. So question 1, you're going to submit an M file named week3_yourname.m that's going to contain your code from class participation in week 3. You should also do that. I think we have that in week 2. Let's check. If we don't, I'll make it so that we do. Week 2, we should have it in week 1 too, but I don't think I do have it. Oh yeah, so we do have that here. So an M file with your name, 01, that one, I'll change this a little bit, but you should be, every time that you're done with class, you should have an M file that has all the stuff that we did in class in, and any notes that you wanted to take. You should make your notes as comment lines using the %. This gives you a couple of different things that are good for you. First of all, typing the stuff into the computer is important because you start to associate things. As you're typing things in, you see them come up on the screen, you see them do what they're supposed to do, you make a mistake, you go and fix it, you see how that works. You're making associations. Programming is like learning a language, and you have to make as many associations as possible when you're learning a language. So definitely take your notes on your computer in MATLAB while you're doing each one of these classes on Wednesday. Then immediately save that M file, upload it into Blackboard, and you will get credit according to its completeness, mostly, whether or not you did it. And then a part of it will also be your style. Make sure that you're leaving spaces between things. Make sure you're labeling things with comment lines. Make sure that you are trying to explain things that maybe aren't very clear to yourself, taking a few notes here and there. So that's where you'll put those. We'll check to see if I'm going to change this question really quick a little bit. Never mind. I'm not going to change it. It'll take too long. So anyway, let's go back to then the home. Once you get your, once I grade things, the way to find those grades is to come over here. I think that you'll have a button called Grade Center, and you'll be able to go see your grade. So on each of these. Notice on the assignments there are points for each of these. Pretty much I give 10 points per problem, even if there's several problems on a single M file. So if you have 5 problems in one file, you'll get 50 points for that whole file, and it'll be 10 points per problem. There are a few problems later on. They get kind of big and involved, so I start making them worth 20 or 30 points each. But for the most part, 13. Okay, enough of that. Anybody have any questions about how you're going to turn this stuff in using Blackboard? Okay. If you want to see videos of class to remember how to do something, you can click on this. Go back to the home page and click on the course videos page. This will take you to a YouTube channel that has all my course videos. Now this has all the course videos from last year as well, but I will start posting course videos from this year. The reason I'm leaving last year's is just in case you want to work ahead a little bit or something like that, or we have our other student that's only going to be watching videos, so I want to make sure that he has them available even if they're still uploading. But be aware that sometimes I get a little boring in the afternoon, a little groggy in the afternoon, so hopefully I don't bore you to death on all these videos, but sometimes they will get a little bit droning on as we get into our second hour plus. So let's talk about programming. Let's go back to MATLAB. So here we are in our MATLAB window. Now, you guys are going to make an M file every day in class. I will not necessarily make an M file every day in class, just because I don't have time to do that while I'm speaking and teaching and trying to figure things out when we make mistakes and other things like that. So you guys still want to do that. So anything that I type up in here, make sure that you're typing also, or at least getting as much as you can. I won't necessarily require to have all of it, but if you only have 3 lines of code, I'll know something's wrong. So let's get into a few things. One of the things that we need to talk about is naming variables. There are certain names in MATLAB that are reserved. So let's say, for example, if I want to name something sine. Sine equals 10, for example. Sorry. Let's turn on the projector. I forgot because I'm making a video of my screen, so our distance learning student will see what I'm talking about, but you guys can't. Okay. So here is our sine equals 10. I've just written sin equals 10 in my command window. And I'm going to hit enter, and that will come up here in a second. It should give me a warning. It used to give you a warning when you did something like this. But the problem with this is that sine is actually a function in MATLAB. For example, if I do the sine of 4, then now I can't use the sine function because I've assigned sine to something else. I've given it a name. I've given it a value. So I can't use the sine function anymore. I'm going to go here to, I'm going to type in help, which is another function in MATLAB that has to be, that is reserved, that is used for something. And I'm going to do help sine, and I'm going to hit enter. I'm going to see what it tells us. So the function sine, S-I-N, this tells us some things about it. And if you want to know more, you can hit this reference page in the help browser. But it's the sine of an argument in radians, and also you can get the sine of the elements of an array. But right now it's just 10 because I've told it it's 10. So I can't use the sine function anymore. So now let's clear that. Let's clear my command window, and let's also clear my workspace so that sine is no longer equal to 10. And let's do the sine of 4. Sine parentheses 4, and I hit enter, and now it knows what sine is again. So you have to be careful what you name your variables. If you name your variables using a reserved word or a word that's been used for a function in MATLAB somewhere, you're going to be in trouble. So how do you decide, how do you figure out which things are being used? So here's one way to do it. The function isVarName, I-S-V-A-R-N-A-M-E, is a function that allows you to check whether or not something is a function in MATLAB. It will give you an answer in Boolean variables. It will either give you a 1, which means it is in MATLAB, it's one of MATLAB's functions, or it'll give you a 0, which means it's not one of MATLAB's functions. So isVarName sine should return a 1. The answer is 1. It is a variable name in MATLAB. You're not supposed to use it. It's not a good idea to use it. Let's try another one. Let's do is, and I'm going to teach you a little trick here. I want to use the same function isVarName, so I'm just going to press my up arrow, and it'll give me all the functions I've used recently. And I'm just going to hit isVarName here, and then I'm going to delete sine, and I'm going to try another one. I'm going to try to use Tom. isVarName Tom. Answer 1. It is, actually. So I can't name something Tom. So I go up again, and I'm looking for another variable name. I'm going to use my name. Is Jared a variable name? Why does it keep doing answer 1? That's not a variable name. Oh, goodness. They've changed something about this, which I'm not sure. Oh, they have. Okay. So the isVarName command is actually not telling you what I thought it's telling you. It's not telling you whether or not it is in MATLAB. It's telling you whether or not you can name a variable that at all. So if I did, for example, isVarName 6 dash Jared, it won't let you start a variable name with a number. It also won't let you use certain characters in isVarName. So if I use Jared and I use the space Jared, it won't let me use two words that are separated by a space. However, if I put a underscore between, let's put a dash between and see what happens. It won't let me use a dash, but it will let me use an underscore, because dash is reserved for minus. So I'm sorry, I apologize for that and mix up that. I believe that used to tell you whether or not the variable was in MATLAB, but apparently it doesn't anymore. There's probably a new function for that, which we're going to have to learn in a bit. I don't see where it is. But another way to check to see if something is, so you can't use isVarName to check if something is used in MATLAB. You can only check it to see if it's a valid variable name to be used in MATLAB at all. But another way to check it, in case we don't find that new function, is to use the help function, which I just used before. Help tells you about something in MATLAB. So if I use help, for example, pi, right? The pi is the name of a number in MATLAB. It's a stored number. 3.1415926535897 and so on. And you can use it in MATLAB. So if I want to do the sine of pi, for example, then it gives me an answer, a very, very small number, which is actually 0. If I want to use the cosine of pi, it gives me the answer -1. So, so if you want to check if one of these, oh, here it is. Here's the new. So if you want to check, here's another way. You can either use help if you use help pi or help whatever. Let's say, for example, I do help Tom, because I don't think that is an actual variable number. Tom is not found. In other words, MATLAB doesn't know what that is, so you could go ahead and use it. But there's another one you use, which is called the which function. And this used to be used for something else, but I've used MATLAB for too long. So if I use which sign, then it will tell you that it is either a built-in variable or not a built-in variable. So this one is built-in, tells you where to find it. If I want to know if tick, for example, is a variable, then it'll tell you it's a built-in one. But if I use which Jared is not found again, so it's not something that MATLAB uses. So that's the new function. It's which. And then his var name tells you whether or not it's a valid name to be used in MATLAB. And then you can also use help. Now there's one other command check that we can use, and that is let's see here. We have a set of words in MATLAB that are used for programming things. For actual, what do we call it? We call it structure programming. So to create structure within your programs, you use one of these words, and they're called keywords. So what you do is you type in the command is keyword, all one word, no spaces, and you hit return, and it will tell you all the keywords that we use when we're doing what we call structure programming in structures. So these are other things that you should not use as variable names: while, try, switch, spend, return, persistent, par for, otherwise, if, global, function for, else if, else, so on and so forth. So that is those are MATLAB's tools for telling you all about variables. So the next thing that we have to do here is to learn how to start to create matrices or multidimensional arrays. Remember, an array is just a list of numbers, but a matrix is going to be multidimensional, so it's more like a field of numbers, you could think of it as. And once we've learned how to make these matrices, then we're going to start doing math with matrices. Lots of calculations all at once. So let's start off pretty simple. If you're following along in your book, we're on page 20, and we're going to move on from there. So a very simple matrix, or a very simple array, I'm going to give it a name. You don't have to give it a name. In fact, I'll start off by not giving it a name. But one way to create a matrix or an array in MATLAB is to put it in between square brackets. Your square brackets are up by your delete button on your keyboard or your backspace button. So you put your array in square brackets. If I put a 7 in square brackets, for example, it creates an array that we call 7. And that's fine. Well, an array that has a 7 in it. Very simple array. If I want to name an array that has a 7 in it, then I do this. I put a 7 inside of the square brackets, and now I've got an array that has a 7 in it, and it says that a is equal to 7. Now that looks a lot like just naming a variable a. Well, it is very similar. But we can also do something like this. We can also say that b is equal to, we'll put in our square brackets back into it, And we'll put a 2 and a space and a 5. Then we'll hit enter. Now we've created what we call a row vector or a row array of 2 numbers, a 2 and a 5. And these numbers have delineations, or they have a placeholder that tells you where they are. And it's always row first and then column next. So the 2 is in row 1, because there's only one row, but it's in column 1 as well. We have 2 columns. And the 5, so that one would be 1, 1. And the 5 is in row 1, column 2. So that would be 1, 2. It's always row, column, right? And you notice here that it shows us our value, 2, 5. And if we click on B over here, it actually shows that it's a 1 by 2. It's 1 row by 2 columns. Okay? The reason that it says a double is because it's using a double byte to store each number. So it's using 2 bytes to store each number so that it's got a lot of, you can put a lot of digits into each one of these things. So it's a 1 by 2 double byte matrix. And you can see that it's laid out with numbered rows and numbered columns. And when I come in here into, this is what we call the array editor, I can actually add numbers to this array. I could put a 4 here, and tab over and put a 45 here, and tab over and put a 12 here, tab up and put a -9 here, and then I can actually save this. If I think that if I close out of it, it'll just give me the option to save it. Let's see if it does. Well, it doesn't, but it saves it automatically apparently. And then I can go down here and I can press capital B again, and it won't give me the same array as before. It'll give me a new array. Because B I have now changed into a 2 row by 3 column, or a 2 by 3 double array. Okay. So there's a couple of different ways you can create arrays. You can create them using this bracket notation, this square bracket notation, or you can use the array editor to create arrays. It's often much faster to create arrays using the array editor. Okay. So just in case you wonder. Now let's create a bigger array. I'm going to create the array C. Well, not necessarily a bigger array, but let's create now a multi-dimensional array with multiple rows and columns using the square bracket method. In the square bracket method to create this array, what I want to do is I want to put in my first row, and you can separate the numbers either by spaces or by commas, it doesn't matter. But I'm just going to use spaces. I'll use a space, I'll use 1, space 2, and then you separate each row by a colon. Sorry, a semicolon. And the next row would be 5, space 7, or I could use 5, comma 7, either way it works. And then I go ahead and I press return. But this time I don't want it to print. Notice that every time I've made an array and I hit enter, it prints it to the screen. If I don't want to print, I go ahead and I put a colon there, and it won't print. Whoops, wrong one. Semicolon. Put a semicolon there, and then it won't print. But it does save the array. The array is over here. It's in my workspace. So I can click on the array, and it's there. And if I go back to my command window and I type in C and just hit enter, then it will show me what the array C looks like. It has a first row with a 1 and a 2 in it in the first and second column, and a 5 and a 7 in the second row in the first and second column. Simple stuff. A simple way to build some simple arrays. Let's see here. If your arrays are similar to each other in their numbers of rows and columns in different ways, then you can start to do math with them. You can add arrays together that are the same kind of array, if they're both 2 by 2 arrays, for example. You can multiply arrays together if they have some matching things. We're not going to get too far into that. But you can do math with arrays, but you can also do what we call scalar math with arrays. In other words, we can scale arrays. What does it mean to scale an array? Well, if I multiply an entire array by a number, then I've scaled that array. I've scaled it up or I've scaled it down, depending on if it made it every number bigger or every number smaller. So let's try it out. Let's just try 4 times C, for example. So let's see if it works. It took the first number multiplied by 4, the second multiplied by 4, the third and the fourth, all these numbers in it multiplied by 4. Let's take c and let's square it. C squared. Did it work? It didn't really work. Why didn't it work? Does this look like c squared? Is 1 squared 1? Not really. Is 2 squared 16? It's not really, right? So it turns out that c squared means something different than we think it does. It does some math, we just don't know what it did. And the reason that it does some math is because when you square two matrices, you're multiplying two matrices, and multiplying matrices is very different than multiplying numbers. We're not going to learn how to multiply matrices in this class. And so we want to be very careful. Instead of doing c squared, we want to use a different mathematics, which we will learn about later. You actually put the c, and then you put a dot, a period, and then you square it. And that tells MATLAB to square each thing individually instead of squaring the whole matrix. So that's something that you have to be careful with when you're doing math with matrices, when you're doing scalar math with matrices. As you have to be aware that sometimes doing math with matrices is not going to give you what you think it's going to give you. So think about that when you look at your answers and make sure it's done what you think it's going to do. So now let's do some scalar operations of some pretty simple stuff. We're going to do some pretty simple math, in other words. We'll start off with just some one-by-one arrays, or just numbers, and then we'll move on to some array math later with scalar math with arrays later. And let's see, do I really want to do that? No, let's move right on to array math. We've already been here. We've already done it. So let's go to excuse me. Let's actually skip over to 28, page 28. And let's learn a little bit more about making some arrays. So let's look at this array here. We'll call it x equals, put in our square brackets. We're going to do 1 space, 2 space, 3 space, 4 space. So 1, 2, 3, 4, right? There's our array. Very simple stuff. There is another way to make this array. What if I don't want it to be a row array? What if I want y equals an array of in a column? Well, then I would do 1 semicolon, 2 semicolon, 3 semicolon, 4 semicolon, or 4 just end it, and then I would hit enter. And now I have a column array. 1, 2, 3, 4 down in a column. This array has 4 rows and 1 column. You just have to make sure that you remember to go from one column to the next. You put in a semicolon in your array. You could also just make an array that looks like this, y equals, put some square brackets in there and hit enter, and it creates an empty array over here. And then you could click on it and you could put the numbers in. 1, go down, 2, go down, 3, go down, 4. That would work too. Close it off, and it makes your array y, 1, 2, 3, 4. And now you come down here and type y, and it brings you that array back. So column arrays, row arrays. We also call these column vectors and row vectors. Row vectors and column vectors. When you have a single row or a single column, we often call them vectors, and as well as arrays. So now let's make an array A equals, and let's make a big array. I'm going to make a big array that goes like this: 1, 2, 3, 4. And then we're going to skip to the next line. To skip to the next line, you can either do a semicolon like we did before, but you can also in MATLAB just hit return. Sorry, not hit return. Okay, so now I'm going to have to open up a M file really quick. So if I'm in an M file, you can do this. You can't do this in your command window, but in your M file you can. I'm going to create an array A equals, put in my squared brackets, and I'm going to do 1 space 2 space 3 space 4, and then I'm going to hit return, and look that it takes me down to right at the beginning of the next line, but not over by the A. It takes me to the next line by the square bracket. Then I can do 2, 3, 4, 5, and I can hit return again, and I can do 3, 4, 5, 6. And then, if I run this file, now how do you run an M file? You can hit just run, you can hit run in time, you can do all kinds of things, or you can save it and then you can type the name of the file in your command window. I'm just going to go ahead and run it and see what happens. It's going to ask me to title it, so I'll just call it untitled and I'll save. I'll replace an old one that I've got on there, and it's going to run it and it's going to create that array that I've got, A. All right? So, there you go. But there's another way even to do this. So let's say that I want to create this same array, A, but I don't want to write in every number. I can actually use some notation in MATLAB to do the numbers for me. If I do a 1 and then a colon and then a 4, like this, it will actually create an array from 1 to 4 with steps of 1. 1, 2, 3, 4 in a row. If I do the same thing, but I do 1 to 4 or 1 colon 4 and then do a semicolon and then 2 colon 5 and then a semicolon, which I always do wrong, semicolon, and then I do 3 colon 6, goodness gracious, 3 colon 6, then it will create 3 rows just like I wanted. One that goes from 1 to 4 in steps of 1, one that goes from 2 to 5 in steps of 1, and one that goes from 3 to 6 in steps of 1. Very simple. What if I want to go in steps of 2? Well, then I go in steps of 2. I say that B equals square brackets, go back in my brackets, and I'm going to go from 1, and I'm going to put in a colon. Then I'm going to go a 2, because that's going to tell me steps of 2, and I'm going to put another colon. Then I want to go all the way to 111. Now let's just go to 11. Let's go to 111, might as well. And then I hit return, and it makes an array of 1 row, and it shows me columns 1 through 12 first, and then columns 13 through 24, 25, 36. This is telling me that this is all 1 row. And if I go over here to my arrays, and I look up array A, which is the one I just did, no, it's array B rather, it'll show it all in 1 row. Right there. So, it's all 1 row. Pretty big though. And if I want to make multiple rows, I can do that as well. And I can choose whatever step size I want. I can make an array C, for example, that goes from, make my square brackets. Let's say I want to start at pi, and I want to go in steps of, so I put my colon there. I want to go in steps of pi divided by 3, and I want to finish this thing at 100. Well, what it's going to do is it's going to create these evenly stepped numbers, and it won't go over 100. So it takes me all the way up to 99.4838, it turns out. And it turns out that there are 93 numbers between pi and 100 in steps of pi over 3. That can be very useful, as you might imagine. So we call this the colon notation for creating arrays in equal valued steps. But there are even other ways that we can do it. Here's a great one. D equals lin space, let's do the one that they're doing, 1, comma, 10, comma, 3. Let's see what it gives us. What did it give us? It gave us 3 numbers between 1 and 10 that are evenly spaced, right? Including 1 and 10. That's what the linspace command does. So if you need linearly spaced or equally spaced numbers between 2 numbers, you can create it very easily. And that can be extremely useful, especially if your linear spacing is extremely small. It's actually 5.5 in 10. Why is it 5.5? Because it's not going from between 0 and 10, right? If it was going between 0 and 10, it would be 0, 5, and 10. But this one is 5.5, and 10, because between 1 and 10, there are 9 numbers, right? And so 4.5 plus 1 gets you to 5.5. But linspace can do that very quickly. And it's especially useful when your linear spacing, when the spacing between, when the number of numbers that you want between two numbers is strange. For example, if I want to go between one, let's do the same command again, linspace, but instead of having 3 numbers, let's say I want 24 numbers. That's an extremely difficult thing to figure out. But MATLAB can do it in the blink of an eye. It'll give you 24 numbers between 1 and 10 that are all evenly spaced.
So then, or D equals linspace, parentheses 1 times 3. What did you do?
So if you do the first command that I did with linspace, the answer is, what does linspace do if I do that first command? Here's the first command between 1 and 10 and 3. It will give you 3 numbers that are evenly spaced, starting at 1 and ending at 10. So the first number will be 1, the last number will be 10, but the number in between will be exactly between 1 and 10. Now the second time I did it was this command, 1, 10, 24. So this is going to give me numbers that start at 1 and end at 10, but it's going to give me 24 numbers total between 1 and 10. Starting at 1, ending at 10, there will be 24 total numbers, and they will all be evenly spaced. There will be even steps between each one of them. Very difficult thing to do by hand, but a very easy thing for the computer to do. Okay? Just another way to make an array of numbers if you need that. This kind of tool to do a linear space numbering system like that is extremely useful for researchers and engineers. For example, you want to paint 100 lines on the road, and the road is 587 meters long. How much distance between each line as you're painting these lines down the middle of the road? And you know exactly how long the lines need to be. This would be a perfect thing to use for that, because you need 100 things between 387 meters, between 0 and 387 meters, right? So, or maybe you need 87 of them, or whatever it is you need, right? So you can make very good arrays using this for doing that. There is one more that is used quite a bit. We won't use it in this class, and so you don't have to worry much about it. But the other one is called log space, which gives you logarithmically spaced numbers. So if you use log space and you go 1, 3, 3, I'm obviously not putting them between my parentheses, then this is what it gives you. It gives you 3 numbers that start with 10 to the 1 and end with 10 to the 3. And they're logarithmically spaced. So in other words, you start with 1 0, you end with 3 zeros. And what's in between? Well, 2 zeros, right? If I do the same thing and I do 1, 5, 3, it will give me 3 numbers. Sorry, it'll give me 3 numbers between 1 and 100,000, I believe. And they will be, the first one will have 1 0 on it, the last one will have 5 zeros, and the one in between will have whatever's in between, which is 3 zeros. Right? Something that is also very, very useful, but we will not use it much because it's kind of beyond the mathematical level of this class. But it's called the log space. So, what kind of math can we do with these arrays now that we have them? Well, remember we made all these arrays so far, and I'm going to clear things out, and I'm going to clear my workspace, and I'm going to start again with a new array called A. My new array will just be 1, 2, 3, I believe, is what we're going to use. Yeah, we'll just use 1, 2, 3. So A equals this array 1, 2, 3. So there it is. What kind of math can we do? Let's do a plus 5. Does it do it? Absolutely. It takes each individual member of A and adds 5 to it. And I can make a new array, B equals A plus 5. And it will create an array B that is 6, 7, 8. So that's one thing you can do with arrays, is you can add them. You can add a scalar to them, and you're good to go. What about A times, let's do A times 4. We already did that. We know that it works out. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. So you can multiply. But can we do A times B? Now both of these are arrays, they're the same size. Can we do A times B? Now what they're going to tell us is that we brought up an error. The inner matrix dimensions must agree for us to do A times B. What that means is that the number of columns in A must equal the number of rows in B, because that's the matrix. We're trying to do matrix mathematics now. So it's not going to let us do that. However, we can do the dot thing. We can do A period B. Whoops. A period B. Period times, rather. You're going to do period and then times. There's our times. And then B. Let's see what that gives us. So remember that A was 1, 2, 3, and B was 6, 7, 8. And what A dot times B does is it takes the first member of A and multiplies it by the first member of B, 1 times 6. And then it takes the second member of A and multiplies it by the second member of B. So if you have two vectors that are the same, or two arrays that are the same, they have the same rows and columns, you can multiply them element by element by element using the dot times function. You can also divide them element by element by element using the dot times function. So that is that. In the book now we're on page 31. We just finished page 30. Now all we have to do for the rest of the chapter this week is to do some examples. We're going to go through some example problem solvers. We're going to solve some problems, and we're going to we're also going to learn a little bit about. We already learned how to make a script file, so we don't have to do that. But the only thing we have to do left really is to create, or to do some problems. We'll also learn something about cell mode. So I'm going to take a little bit of a break right now and we'll get a drink. And then we'll come back here in 10 minutes at 1 o'clock to finish up and do some example things.
Yeah, I took one because I know
Yeah, are you supposed to take it like the top or the bottom?
the top. Because the bottom one it doesn't say it.
Okay, because I just copied and pasted it, so
And you can copy paste.
Well, like, it's like, are you supposed to like be answered it or no? Or like, it's because the top one you can't be answered, right? Or can't.
If you run it, you can.
Oh.
F5.
What?
So I'm taking notes.
So it was wrong to not.
No, I did the homework. So I didn't know this.
Oh, okay, whatever. Bro, I didn't. I didn't do it. Double black, I think, right? I still have it, yeah. You know?
The homework example 101,
You can go to library by the
you can, but I mean, I'm gonna be copying, I don't be copying.
Okay. We're ready to start again. Got some calories in my system and some water in my system. Hopefully my voice won't give out.
They went to the library.
What's it? Oh, did they? What for?
They want to see if they can get a
Oh, like this book?
book. Yeah.
Well, I could have loaned them one of mine. I don't know if they have one of these at the library. I don't think so. But anyway. Whew. Okay, time to start again. I'm running out of energy, so time to get going. Let's take a look at this example 2.2 on page 32. We're going to create a conversion table of pounds force to newtons force. So pounds are one way to measure the force. We usually use it to measure the force of gravity on something's weight, but we also use it to measure the force of, for example, something hitting something else. That's often done in pounds. But newtons is the same kind of deal. It's just in the metric system. It turns out that there are about 4.4 pounds per newton. Let's see, no, 4.4 newtons per pound. Newtons are smaller than pounds. They're about a quarter of a pound. So, first of all, we kind of want to think some things through first. We want to say, what are we trying to put into the computer? Because there's always some input. What do we want the computer to do to it? And what do we want to get out? We want input, computation, output. Pretty straightforward. So the first thing that I'm going to do is I'm going to go up here to my little M file and I'm going to delete this. And I'm going to put my name up here because that's what I do. And I'm going to also put an explanation of what this is. This program will convert pounds, libs, to newtons, right? So I've given it, I've put my name on it. You might also want to put the date on it or what assignment this is if it's an assignment. But I'm just going to put my name. This program will convert pounds to newtons. And then I can go ahead and start doing what I do. So input. I'm going to label my input. Input pounds. Right? So maybe I want to, what it says here is that we're going to create a conversion table of pounds from force to newtons, from pounds force to newtons force, and the table will start at 0 and go to 1,000 pounds. Okay, no, so go to 1,000 pounds at 100 pound intervals. So we know how to do that, right? We're going to create a, I want to make my table go vertically. I think it's cleaner. So we're going to create a vector that goes vertically. And it's going to go from, and we're going to call this thing pound LB force, pound force. And we're going to say that this is going to be equal to, it's going to be equal to this array of numbers that goes from 0 to in 10 foot or in 100 pound steps, and it's going to go to 1,000, right? That's great. And then I'm going to create a table for newtons. The newtons are going to be equal to the pound force table times some conversion factor. Well, that conversion factor is the conversion factor that that they told us, that 1 pound is equal to 4.4 newtons. So we take the pounds and we multiply by 4.4, and it's 44822 or something like that, newtons. So there's my conversion. Now these two lines haven't been explained much yet. And notice that I'm suppressing the output on the end. I'm putting a semicolon on the end of each of these so they don't always print everything to the screen. But I haven't explained this yet, so I'm going to go ahead and explain each of these lines by putting a little explanation. Well, I did explain the input pounds. I'm going to just move that down to here. And then I'm going to do one here, input input conversion. So there's my conversion calculation. This is not an input, this is just my conversion calculation. So I'm going to say this is my conversion to newtons. So now I know what I've done there. And then the last thing I'm going to do is, what else do they want us to do? Oh, then they want us to make a table out of these things. Well, let's go this far. Let's go see what this does. Let's check this and see what happens. I'm going to go ahead and run this. And it's run it, and it's made two arrays. The first array that it made is a row array. I didn't want a row. I wanted a column, so we'll have to fix that. And then the second one is the Newton one. It should show me 4.4 for one, and it does, and onward, and it does. So that looks like it did the right thing, but it's also a row array. I wanted two columns. Let's go back to here. If I, for example, if I put in LBF for my pounds force, it shows me all these rows, and that's not a very easy thing to read. So I'm going to show you guys a new little tip, a little trick you can use in MATLAB. This row array can be changed into a column array by putting a single quote mark after it. Just a single little hash mark up there, just the single quote. What it's going to do is it's going to turn a row into a column or a column into a row. And what it does for arrays that have rows and columns is it will just turn all the rows into columns and all the columns into rows, okay? And this is what we call a transposition of the array or the matrix. So LBF as a column looks like this. And that's more like what I wanted. And Newtons as a column looks like this. And that starts to make more sense. Notice that they've got a multiplier up here. These are 0.4448 times 10 to the 3. This whole thing is times 10 to the 3. So you have to multiply all these times 10 to the 3 to get the right answer, which is a little confusing, but it's just the way it is. So we need to change a couple of things. First of all, I don't like that this is times 10 to the 3. That's not very easy to read. So what I'm going to do is I'm going to change what system we're in. Right now we're in the scientific notation system, and we can change which system we are to go to make it something else. If we go to page 38, they start with this idea of display format, and you can do format long or format short E, which is what we've got here. We've got format short E right now, where it uses this little e to show you the scientific notation. And I don't really want that. I want to just do format short. So I'm going to change to format short, and then I'm going to look at my newtons as a column, single quote. And it still changed it. It still didn't do it. Let's do format long. Try that. Format long. There we go. And let's look at newtons and see if it'll change it. It kind of, it didn't really even change it that way. Still put that times 10 to the e. Well, anyway, we'll worry about that later. We'll try to fix it another time. We'll live with that for now. Let's just go back to format short. And so I've got these two things as columns now. I know how to make them columns, but how do I put them into a table so that they're right next to each other? Well, I'm just going to make a new array. Let's call it table. My table is going to be an array of two columns, okay? And my first column is going to be, or it'll actually be two rows, now that I think about it. My first row is going to be a column, though. So it's like, well, it's just going to be one row, two columns, but two columns. So anyway, the point being is I'm going to put LBF first with the little quote mark after it, the single quote, so that it makes it into a column. Then I can either do a space or I can do a comma. I'm going to do a space because I think it looks cleaner. And I'm going to do my newtons with the single quote mark. And let's hit return and see what that does. It gives us now a table where 0 newtons equals 0, or 0 pounds equals 0 newtons. And here we have 100 pounds equals 448 if you multiply by the point times 10 to the 3 on each side, and so on and so forth, all the way down to these. So we've created a conversion table. Let's go to help format and see if we can learn how to format this into the way we want it. So here we have format hexadecimal, format bank for dollars and cents, small integers, format short E, long E, short G, long engineering, let's try format rational really quick. See if that one works for me. Format ret. And let's do this table again. Yeah, that looks a little bit better, except it gives us these fractions on the right-hand side. So it gave me my 100s over here, but it gave me weird fractions over here. Not the best idea in the world. Format short E. Still gives me the E to the whatever. Oh well, we'll just have to live with it for now. We'll learn it later. We'll learn some other stuff later. I'm going to do that. Okay. So we now made our very first simple table. Let's do another one. Let's calculate drag force. So this is example 2.3 on page 35. One performance characteristic that you can determine in the wind tunnel is drag, or drag force. It's friction that acts all around a three-dimensional object as it's moving through a fluid. In this case, air. We're going to talk about the Mars Climate Observer, which is oh, sorry, no, we're not. I took my glasses off because my head hurts, so I can't read now. So I'm going to try again. So anyway, drag force. Drag force can be calculated using the equation drag equals the C sub D times rho times V squared, which is I guess that's the V, the velocity squared, times the A, which is the cross-sectional area of the thing, divided by 2. And so we have all these different variables that we're going to have numbers for when we get into MATLAB. You may be very tempted at first to just type in this equation. Let's try it. Drag equals C, to do a sub, we do underscore sub D times rho, which would be RHO rather, times V squared, dang it, V squared, there we go, times A divided by 2, and then hit enter. Okay, so right away it tells us we have an undefined function or variable C sub D, C underscore D, because it doesn't know what C sub D is. It also would tell us if we kept going, it wouldn't know what rho was, or V, or A. We don't have any of those things over here in our workspace. MATLAB does not know how to do symbolic math. Okay? Symbolic math is the kind of math that you do without numbers, with variables instead of numbers. MATLAB doesn't know how to do it. At least in what we're doing here. It does have the ability to do it, but you have to either be very creative or use a module that's called Simulink. But we're not going to do either of those things. we're going to first enter in all of our inputs. We're going to enter in all of our information. And we're going to give that information names. And then we'll enter in this equation where the names of our inputs are going to match the names of the variables in this equation. So, inputs. We're going to do input and then calculation and then output. So we have C sub D, we have rho, we have V, and we have A, and all those things are given to us. Actually, that's not true. They actually give us the drag, they give us rho, they give us velocity, and they give us A, and they want us to calculate the drag coefficient, C sub D. So we need to rearrange this equation so that it's C sub D equals something, and then we need to use it. But we can still enter in the stuff that we know. So let's enter in rho, RHO. MATLAB knows what that is, I believe, if I remember correctly. And rho is going to equal 1 times 10 to the minus 6 kilogram meters per meters cubed. So 1 E, that's times 10 to the negative 6. Now, don't try to type in units. It doesn't know what kilograms per meter cubed is. So just type that in and call it good. Then we have V, our velocity. I'm going to use a little v, so I don't have to keep typing big V, little v. V is 100 miles per hour, but this needs to be in meters per second. I'll just put it in as 100 miles per hour. We'll convert it later. And then A equals 1 meter squared. So that's my area. A equals 1. We want to calculate the drag coefficient. If we rearrange the equation, we will get that C sub D equals drag times 2 over rho times V squared A. So we need to know the drag also. They actually told us the drag, I just skipped it. So the drag is equal to 20,000 newtons. So we know that one as well. So we've got all the variables that we need, but we still need to do a conversion. If I was doing this up here in my script file, I would do this. I would say convert miles per hour to meters per second, and then I would do the math. I would do this conversion. Turns out to convert miles per hour to meters per second, you have to first multiply by let's see, you multiply by 3,600 and you divide by 1650 or something. No, it's the other way around. I don't remember what it is. That's what Google's for. So we'll go to Google really quick. And we'll go MPH to meters per second. We'll get a conversion for us right away. 0.447 is the conversion from miles per hour to meters per second. So we go back to our MATLAB. What was it again? 0.447? 0.447. So to convert this, we're going to write an equation that looks something like this. Our speed, our velocity, in meters per second, which I'll call capital V, which will equal my little v times 0.447. So there's my conversion. I can also just put that in my command window. Copy that, put that down here, paste it. And now I've got big V for my little v, which happens to be 44.7 meters per second. My new equation is C sub D, which is my drag coefficient, equals, what was it? Equals the drag, that's one of my variables, right? Times 2, divided by, now when you divide by a whole bunch of things, you have two ways that you can do it. You can either just divide by rho, divide by v squared, divide by a, do 3 different divisions. Or the cleaner way is to divide by some stuff in parentheses. So in this case, we're going to divide by rho times capital V squared times a. That's the way I would recommend it because it's easier to read, easier to see what's going on. But then we've now calculated C sub D and we hit enter. And it gives us our value, 2.0019 times e to the 7 Let's see if that agrees with what they got. Yep. 2.0019 times 10 to the 7. So that is your program for that problem. Now in the book, they actually write out the solution by hand first. It's not a bad idea to do. In fact, it's something that we will learn about in the next couple of homework sections. Well, in the next, when you're working out simple math problems, like this one's not that hard, I wouldn't worry about it too much unless you're messing up the equation somehow. But when you start to write really complicated programs, you are definitely going to want to map them out by hand because it's going to get really crazy. And that will happen in this class eventually. And we will learn the methods that are used by programmers to do that. So there's our first example, calculating the drag coefficient of an airplane. Let's see. What else? Remember that when you're doing this for your notes for the class, and when you're doing this in your files for your homework, you're not just typing stuff in the command window. But I'm going to do that a lot in this class just because I don't have time to do everything else. But you would want to make sure that the stuff that you're typing down in here has some explanation. For example, C sub D equals drag times whatever, and then you'd put in your percent sign, and you would explain this is the drag equation solved for C sub D or whatever, right? So you remember where that equation came from. Don't just assume that everybody knows. Also notice that my program here has lots of white space. Spaces in between things. Okay, if you put two things together that are related, that's fine. Or 3 or 4 things, even 5, 10 things together that are related, that's fine. But I recommend white space wherever you can justify it. I'm moving on to another new idea. This line of code does something different. I'm going to set it apart. Make some white space. You're not wasting paper or anything here. It doesn't make the program run any faster or slower. It doesn't change anything, but it does help you to see what you're doing so you don't have to fish through all this code that's really tightly packed. It can be really confusing to the eyes. So make sure you're leaving white space. Make sure you're leaving lots of comments. The next example on page 48, we're going to calculate the acceleration of a spacecraft, but this time we're going to do the entire program inside of an M file and then just run the M file. And that's great. Let's do it. So here we have the aircraft. They tell us that force equals mass times acceleration. They tell us that work equals force times distance. They tell us that power equals work over time, which equals mass times acceleration times velocity. They're giving us all these crazy equations. I won't give you crazy problems like this for the most part because these are more physics than they are programming. But they're going to do the problem. Notice that they do the problem by hand on page 49. And we don't necessarily have to do a physics problem by hand. But notice what they do. Their first thing that they do is they figure out what the problem is. They're stating the problem. Then they're going to describe what is their input and their output. That's something you always have to describe. But I also like to always describe what we're going to calculate. So describe input, calculation, output. In this case, we need to input mass, power, and 2 velocities, it turns out. Because we're going to calculate this for 2 different spaceships. So mass, power, and 2 different velocities. The calculation we're going to do is down here under number 3, where it says we're rearranging this equation, power equals mass times acceleration times velocity, to be acceleration equals power over mass times velocity. So now we know what our inputs are and what we're inputting them into, what our calculation is going to be. And then our output, of course, is going to be the power. So we're going to now build our MATLAB program in this M file. So let's do it. I'm going to erase everything in this M file except for the first couple of comment lines. This program will calculate the acceleration, I'm just going to call it Excel, of Voyager 1 and 2 from the mass, power, and velocity. Great. Notice that as I go down to a second line, it automatically puts in a comment line for me. Because you have to have a comment, you have to have a little comment % sign for every line. I'm also going to write in here the inputs. I'm going to say the inputs are mass, even though I wrote it kind of up there anyway, mass, power, and velocity, just so it's clear. You might put in the date or whatever else, and actually I'm going to set that one off by a space as well, so that I can start putting in inputs. But however, the first thing I'm going to do at the beginning of this program is I'm going to make sure that the command window is clear and that the workspace is clear. So I'm going to go ahead and put in a CLC and a clear right at the beginning of my program. It's not bad programming technique to do that at all, because it just clears everything out so that you're starting fresh and you don't have to worry about what's already in the memory. So I'm going to start with a CLC and a clear. And sometimes people like to put those on the same line, which is totally legal. If you put a clear comma or CLC comma clear, it will do that. Next line. I like to put in a space after that because that's something different than my program. Maybe I want to tell myself that this is example 2.4. They do that in the book, so we'll do it too. And then they do their explanation of what the problem is down here, and that's fine too. I did mine earlier or whatever. They're going to change their format to short G, which is just another kind of formatting we can. Let's see. Let's go back a couple pages and read what short G is. What it stands for. Short E, short G is where MATLAB selects the best format. Okay, so for short G, we're letting MATLAB make its best choice. So format short G, that's great. Now I'm going to start entering in things. Now, if you don't remember what short G is, you can go ahead and comment this. MATLAB chooses best, right? But I'm going to get another space there because that's not really part of the actual program. That's just something to make things work out cleaner in the end or whatever. But I want to go ahead and start my program now. I'm going to start by entering my inputs. I'm going to start by entering a mass. Is that what they do first? Yeah, they do mass. So I'm going to call it mass. Mass will equal 721.9. 721.9. You'll notice that in the MATLAB book, they don't put a space between their equal signs and things. And numbers. I like to because it just, again, gives me a little white space to work with. And then we're also going to enter in, and they do some comment lines here. And these are good comment lines. This is the mass in kilograms, so we know what the units are, right? Somebody that comes in doesn't replace the mass with something in stones or something. Let's enter in our power. Our power is equal to 335. And instead of saying that it's the mass or the power in watts, I'm just going to say in watts, because I know that power is power. And then I'm going to do velocity. Now there are two different velocities, one for Voyager 1, one for Voyager 2. And so I'm going to do velocity. I'm going to call it velocity. I'm going to call it velocity, VAL. I'm just going to let it equal the two numbers, but I need to put these in an array. So I'll go ahead and put it in an array. If it's a row array or a column array, it's not really that important. We're going to go ahead and do a row array, 3.5, and then space 3.15. and I'm putting semicolons after each line of code so that I don't print these all to the screen all the time, so that I only get the answers out that I'm interested in. So this one is in meters per second. Go ahead and label that. Okay, looks like we've got everything. Oh no, sorry, it's not. Not in meters per second. This is an AU per year. You know what an AU is? AU is an astronomical unit, which is the distance between the Earth and the Sun. So we're going to have to convert something. So it turns out that to convert this, we're going to have to use a conversion factor, which is actually given to us in the problem. It turns out that there's 150 times 10 to the 9 meters per AU. And then there are, they do this conversion halfway through the page on the line that says V. It turns out that it ends up being the velocity for Voyager 1 ends up being 16,650. So we'll just type in that number. Or maybe we'll just do the conversion for them. Yeah, they actually calculate the conversion on the line. Oops. So the conversion is, let's put a space here for our conversion. We'll set this apart a little bit. Convert AU per year to meters per second. And we're going to have to take our velocity vector, VL, and we're going to call it, we're going to say velocity now. We're going to call the new vector, we're going to call velocity. It'll be equal to our old vector velocity, just VEL, times 150 e to the 9, which converts it, the AU, to meters. So that's our meters conversion. And then to convert to years, we need to take, there's 1 year for every 365 days, so we divide by, or we multiply by 1 over 365. And then there is there's 1 day for every 24 hours, so we multiply by 1 over 24, which is divided by 24. And then there are 3,600 seconds per hour, so we multiply by 1 over 3,600, so it's like dividing by 3,600. So we have these three divisions here, 365, 24, and 3,600 to convert all the years to seconds. So there's our conversion. That gives us a new vector velocity. I'm going to give myself another space to go back to calculating, and I'm now going to calculate the acceleration in meters per second squared. So that's the next line. And acceleration is just, I'll just call it acceleration right there. And maybe I'll just give it more description. More description is not bad. I'll call this the acceleration underscore of underscore Voyager VOY1, and then I'll do an underscore and underscore VOY2. It's not bad to have a very descriptive name for something. And the acceleration is going to equal the power, which we already have. We're going to divide that by the mass times the velocity, but remember, we're dividing now by the velocity, which is an array. So we have to do a dot divide. When you divide by arrays or you multiply by arrays, you have to do a dot divide. So we're going to dot divide by the mass dot times, because we're now multiplying by an array, velocity. And that we want to print out to the command window. So that's my program. I'm going to go ahead and run it and see what happens. You can see that it erased everything, both in the workspace and the command window, and it's calculated everything. We've got Voyager 1 and Voyager 2. I don't know if we got them right. Let's check to see if we got them right with the book. .78 and 3.09 times 10 to the minus 5 for both of them. Yep. So, there we go. So one last thing that we're going to teach you here, and that is the use of these M files, these script files, to do multiple problems and to run multiple things within them. Because you will often be putting lots of problems within these things. The first way to do this is to use what is called the pause command. So if I run this program and then I hit return here and I put a pause in here, it will not do anything else in that script until the person using the file, using MATLAB, hits a button on their keyboard. So if I put pause and then I do a new thing like 4 plus 5 here, then I run it. It's going to run. It's going to give me the same thing. But notice that it didn't give me a new cursor. It didn't give me a new prompt. So I can't start programming the command window. I have to come down to the command window and click in the command window. And then I have to hit a button on my keyboard and it'll do the next thing, which is 4 plus 5, where the answer is 9. Now it's given me the prompt, which is this double little greater than sign. Now I can start programming down here again and do whatever. So that's one way that you can separate your programs or separate your problems within a script file. The other way is to use what we call cell mode. To do cell mode, we're going to go to to learn cell mode, we're going to go to page 50. So we're at the end of our first problem, and instead of doing pause, we're going to go to the beginning of our first problem. We're going to go to the very beginning, and instead of putting 1% sign, we're going to put 2% signs, and that will create what is called a cell. It's the beginning of a cell, and it'll highlight the cell in yellow, and it will go all the way until the next double percent sign. So instead of my pause, I'll put a double percent sign, and I will call this problem 2, or whatever. And then after this one, I could do another one, and you could keep separating these things off by cells. Your first cell, the first cell that you create, will be highlighted. Let's see if I can make this second one end here. So the first one that I've got here is, let's see, what did I do? Oh, right. Okay, so whichever place you click on, whichever cell you click on, will turn yellow in the script file, but they'll always be separated by these little gray lines, right? And that's what we call cell mode. Now at the let's see here. If I save this, I save my script file. Then I can go to up here to. Let's see, which one is that under? It's under Editor. Oh, it's under Editor. If I go to Editor, and I go to, I believe it's breakpoints in mine, but it might be, no, it's not breakpoints. Go to Editor, and then I go to Navigate. Here we go. Go to this button up here, Navigate. Then you can go to different sections within your file just by going to the Go To. You can also search. You can find different ones. Or you can hit an arrow to go back and forth in your file. If you have a bunch of these different ones all named different things, they'll all be listed up here. So I have example 2.4 is one of them. Section 1 is another one. So, because this one doesn't have a name, I guess. Anyway, that is using cell mode. I don't really care which way you do it. I think the pause method is the easiest. It's simple for me. It's simple for you. Doesn't confuse. You don't get confused with all your little percent signs in there.
Does the blocking do the same thing, or is it?
No. Breakpoints and blocking do different things. And I don't remember exactly what they do, but we do learn that later. Let's see, did they talk about blocking in this chapter? I thought it was a different chapter. think it's a different chapter. This thing, MATLAB, has so many different things that you can do to organize your programs, and we will only learn a few of them. But we will learn some breakpoints. I believe we do that at one point because you have to do that for debugging. Well, it's really nice to do that for debugging your programs. And blocking, I believe, is done with structures. And so I think if we hit that, it'll be in our structures chapter. So that takes us to the end of chapter 2. And in chapter 2, I've given you 6 problems, I think, for the first week's assignment. And then I've given you a similar number of problems for the second week's assignment. If you haven't finished the first week's assignment, you can still go turn it in. But don't get behind, because it's really hard to make up programming. You really want to work on the programming today and tomorrow that we worked on in class today. You don't want to wait until next Monday and Tuesday or Wednesday morning, because you will forget everything we learned in class today. But it's important to do it all at once so that we can learn as much, we can have as much practice on it at one time as possible, right? This is why I do this once a week, is so we can get a lot of practice all at once, and then you go to your homework, and then you bring your questions to me next week, okay? So get in that habit. Get in the habit of coming to class, doing the work in class, immediately starting on the homework, either Wednesday, Thursday, or Friday at the latest, and then on Monday and Tuesday next week, you bring your questions to me either by email or in person.
What's the homework for chapter 1?
It's in Blackboard.
Oh, it's on Blackboard?
Yeah, it's on Blackboard. I don't think you were here for that. Let me show you that really quick. Do you know how to get into Blackboard?
Yeah.
So if you get in, I'm pretty sure that you're all in my Blackboard class. Let's check it really quick. Yeah, you're all there. So if you get into Blackboard, the front, I only have one page for this class. It's just this home page. And go to weekly assignments. The first thing that you'll see on the top of the page is the document that you're supposed to add to every week. So you should have added something that you learned in MATLAB this week, something that hasn't been put in the document before. And if you didn't do that, go do it. And then you do it again for this week, for this coming week. And this is something you do after class, not before class. You come to class, you start your programming, you're going to learn something while you're programming. Either MATLAB will teach it, or you'll learn it through the book, or you'll just accidentally learn it, or you'll Google something. If you don't know how to do something in MATLAB, if it's not making sense, Google it. Google is your best friend when you're learning programming. Because there are videos out there, there are forums out there, there are people online live 24/7 trading ideas in programming that will tell you how to do it. In MATLAB, they'll sit there and tell you. So you've got all kinds of great opportunities to learn stuff. But when you learn something that you think will be helpful to other people, type it in here. Put your name, your date, and tell us about it. Tell us how to use it. Make sure it hasn't been done before. Then the next thing is the assignments. Week 1 assignment is right here. These will be open. They don't really have a due date on them. They do have a due date, but that just tells me whether or not you're behind or not. Okay? So that I know when you've turned things in. Otherwise, I'm just going to leave them open. You can turn things in late. It won't cost you any points, but unless you're like 4 assignments behind, then it will start to cost you points, mostly because I'll just be frustrated grading late assignments, and I won't be very nice, right? So then the earlier you get them in, the nicer I'm going to be, and the better grade you're going to get. But you just go in here. The first question in each one is going to be, and this one doesn't have it, but in the other ones it does. This one has, you watch this video and you create an M file. I'm going to probably change that. But the rest of them have, the first question is, submit your notes from class that you made on MATLAB. So you save your file that you've been typing things into during class. You type in all the stuff that I type in and try to get it to work for yourself. And once you've done that in class every day, then you can just turn it in. Make sure that you're getting some good comment lines and leaving white space. And put your name on it. Save it as the file that I've told you to save it as. And then question 2 here has several problems in it that you'll do. It looks like 7 problems, each worth 10 points, because the whole thing is worth 70 points. So you go through here and you do these 6 problems. It's not 7 problems. And then you come over here to the rubric. You can look at the rubric, which shows you how this will be graded. You know, for unsatisfactory completion, you'll get 7 points out of the total, but if you do really well, you get 35 out of 70. Half your points will be for completion. And then so on and so forth. So that's where the homework is now. It's pretty close, not always, because sometimes I've added in some problems that I thought were helpful to help you with the next part. But it follows the book well enough that you can look through the book and find good examples of how to do it.
Oh man, no, it's-
Not a problem. If you have a problem, just open up your book and open up MATLAB on your computer and start doing everything that they do in the book. Because that's all we're doing in class. Plus a little extra.
Could we, like, I know we just meet like today, but could we like ourselves meet like every day?
Absolutely. If you want to work on MATLAB in the lab here while I'm in my office, you're welcome to do that. You just have to be here at the time that I'm here or make an appointment so that I can be here. But I would highly recommend that you get this on your home computer. Get it on your own you have a laptop?
I think we like just super slow,
Okay, MATLAB does not take a lot of power to make the files. It might take some power to run the files later on, but to make the files, you're just creating a text file. So it's not terribly difficult to do this with MATLAB. I think that I have 10 total licenses. So I could load MATLAB on some library computers if necessary.
I don't think better, honestly.
Okay.
My computer.
The problem with running them on library computers is sometimes it takes forever because I have to have the text do it. They won't let me do it. So I have to have the text do it, and that can sometimes take weeks to just because I have to get together with them, I have to sit down, we have to make the license, we have to make sure it's working, we have to make sure it's accessible. It's a real pain in the butt, but I will do that if you want. So, would you like it on a PC or a Mac in the library?
It's probably better either on Mac or
Okay. I'll put it on one of the Macs in the library, and you can go and use it. That will probably be easier for us. Anyway, so. Any other questions? Okay. Yeah, and again, if you're not sure what we did in class, if it wasn't making sense to you, if we're going a little bit fast, we do cover a lot of stuff. The videos are available. If you go back to the main page here, go back to the home page. I've got videos from last year and this year, so you can watch two versions of the videos, whichever one is more interesting to you, I guess. If one puts you to sleep, watch the other one. If that one puts you to sleep, then you're in trouble. Then Google something. But these are the videos from last year, and I'll start uploading videos starting today from this year. So, okay, if there's nothing else, we'll go ahead and break for today, and we'll see you guys next week. I will be in my office tomorrow from about 11 o'clock until 1, and Friday from noon to 1, I think. Unless you have an appointment, you want to make an appointment with me. So, have a good one. Let's stop this video.